Ladies and gentlemen, in this talk I would like to approach the microbial issues from the point of getting to really know them, to become familiar with the microbes, because every so often when people, common public and even scientists, we discuss about the microbes, it's something like more or less threatening, and we feel like that we should be cautious with them. And that's true, but it shouldn't overwhelm the need to get actual information on their behavior and on the importance of the microorganisms in our lives and in the environment. So now I'm trying to take up some points, a few points regarding this. First of all, is to remind that we have the celebration of our centenary in Finland this year, and for that purpose there is the Flagging Day for Nature on the 26th of August, and this is the first time in the world that any nation is declaring the flagging for nature, so this is done in Finland. And so I'm glad that we are here now during this year, and we have the opportunity to study the great nature and the circulation in the ecosystems which keep our lives and which are providing us all that we need on Earth. Energy is flowing, and that makes the materia circulating on this planet. And this is the case also in our body system and within the digestion and regarding the microbiome that's existing there. And it was almost 100 years ago, exactly 90 years ago, that the researchers in the University of Yale in the United States, they found out or concluded that actually duodenum, which comes from the gastric or after gastric areas, it's maybe the most important part of the entire alimentary tract, because in there the microbes meet the incoming food, and from there they start to participate in the absorption of nutrients. Even though the amount and concentration of bacteria in the upper small intestines is very low compared with the colon, nevertheless it's the crucially important part of our microbiome, as we hopefully will see soon. And we need this type of new approach to understand some background of several human conditions, both in health and in disease. And together with food, we receive plentiful of microbes from the environment. And after the gastric hydrolysis process, the food is sprayed into the duodenum. That is the narrowest point of our digestion, just after the stomach. And it's not slowly defunding, but it's sprayed fast. And at the same time, the pancreatic bicarbonates are starting to neutralize that stuff. And so the pH, which is 1 to 2 in the gastric areas, it is rather quickly high up to 6, which is the normal pH of healthy duodenum. And the bacteria start to grow. But they merely grow inside the food, and they start to convert it into chyme. That's the term for the substance that is formed by all the food that we digest, and bacteria take part in that digestion. And in order to keep the surfaces clean enough, our body system has many tools or weapons. And that's very important, because otherwise we won't get nutrients enough. The microbes would grow on the surfaces in too high numbers, which would prevent the absorption. And that's the case in some instances, like in the irritable bowel disease and such. But at the same time, what we have found out is that, in fact, microbes don't so much battle against each other, but they always would like to establish a balance. A good balance if possible, less good if necessary, or if somehow restricted. So this means that the common strive in the microbial nature is to form balances which benefit all the members. This is an example of some of the human body mechanisms which to prevent excessive growth. There are these defensive peptides on the epithelial surfaces, and they are acting as like antibiotics. This is a bit complicated slide, but the essential information is that these are as effective as antibiotics, if not more. Sorry. And similar peptides we find also in the animal kingdom. On Friday, on tomorrow, Professor Lebedev will lecture on the Macain peptides. And amphibians, such as frog, they produce these peptide molecules to keep their surfaces free from inflammation. And surprisingly enough, the old folks already seem to have known it, because in Finland, the farmhouses collected excess milk into the containers, and then there was lactic acid fermentation which preserved it. But the problem was that the milk was eventually acidified. So acetic acid bacteria were then processing it further to acetic acid. And to prevent that, they put simply a frog into the container. And the poor frog was bound from his or her leg, and he swam there all the winter. So I don't know what the modern animal protection would say about it, but that was practical in those times. And the same thing was there in the well. When I was a small child, I was taking water from a well like that, and there was then a frog in the container. And so I shouted my mother, "Hey, there's a frog. It's disgusting." And she said, "Don't worry, it's good for the water quality. It keeps the well and the water clean if you have frogs there." She probably didn't know anything about Macains, and so didn't I at that time. So I just wondered why on earth a frog can keep the well or such a thing clean. And on the right-hand side, we can see the results from a study which we did with Professor Lebedev and his group. In here we have a situation where Staphylococcus aureus was growing without any peptide in the PMU, portable microbe enrichment unit equipment. In here we had the concentration of 0.01 milligram per milliliter, so we need some weakening of the growth. And in here 0.03 milligrams per milliliter. That was enough to prevent completely the bacterial growth. And it was published in 2012 in Journal of Proteome Research. But as we already stated, these protective mechanisms, they do exist also on our body surfaces, on the epithelia, on the skin, on the retina of eye, in mouth, on teeth, and of course inside the intestines. We have all these antibacterial peptides which keep the surfaces clean enough. And we have antibodies. We have also a membrane antibodies, ICEI group of antibodies. Always I do it wrong. But how to add prevention? We know vaccination, that's active immunization. But we can immunize passively as well. We can produce the antibodies elsewhere, outside our body. And I know at least two ways to make it safely. One is to immunize a cow and collect the colostrum milk, which is full of antibodies. And the other is to immunize chicken or other bird and then take the egg yolk, which is containing IgY antibodies, which position themselves on the surfaces as like human IgA. And it was already 25 years ago, the Japanese, as Professor Schoenfeld told us yesterday, if you invent something, go and see if the Japanese have not invented it yet. So that was the case also in here, that the Japanese have published it long time ago. And they fed the rats with IgY antibodies. And they gave them also sugar-containing diet. And so those reference mice which were not getting the antibody, they were developing lots of caries. But those which got the antibody, they didn't. And the effect of the treatment, it lasted about a year, so it was very effective. And that was based on the fact that this antibody was shaking the balance between the microbiome in the mouth. So little things can mean a lot in these microbial communities. And then we come from the mouth to the stomach, and it was 1995 that it was established that the stomach is not sterile. Until then, we had believed that there are no bacteria or other microbes in the stomach because of its acidity. But that was not the case, or is not the case, and Helicobacter pylori was found. And it was found out that it's producing a kind of polysaccharide capsule which is protecting it against the acidity. And later on, many researchers have found out that there are also other microbes and bacteria on the stomach walls. For example, the lactic acid bacterium. This is from our study where we took endoscopic samples from the gastric membranes, the three areas of the stomach, cardia, antrum, and pylorus. And there were 13 healthy middle-aged individuals, and we collected several samples and found out that all patients, first of all, had these lactic acid bacteria, and most of them had these on all of the areas of the stomach. And then we come to a different kind of system of digestive tract, which is there with the ruminants. And this is a real beauty in a way, that the microbes, they do the job for the cow or for the American bison or for any other ruminant. Just dry grass and big animal is sustained by that, and it's producing lots of milk. So we wanted to implement these principles also in the biorefineries, and that's how we started to think about the development of microbial biotechnology based on undefined mixed cultures. Because in industrial microbiology, so far, usually the industrial strains are all classified and known, but in our case we added industrial strains into a community inside the reactors. Here's one example. We got a lot higher production of mannitol from a process where we were using rumen bacteria. And mannitol is very valuable. It's maybe €5 per kilogram, and it's used for many purposes. And increasingly, it's going to be the substance for the medical tablets and pills because it's dissolving in the mouth. And we could make it with the rumen microbial culture on a very high production level compared to the previous systems which were based on aseptic cultures. And by the way, if you get some xylitol chewing gum which containing more mannitol than xylitol, mannitol is the substance which is making the sweet fresh. It's non-toxic, so it's very useful for many purposes. It's just one example, and a few years ago we had the project implementing advanced concepts for biological utilization of waste, and many people in this hall have somehow contributed to that. Professor Dahlqvist was in the Swedish group, then Hakalehto, our lab manager, and Ari Jääskeläinen was the project manager of the EU project. We had the Baltic Sea region project with 6 nations, and myself, I was the key technology provider, and Ari was the manager of that project. One example of the complexity and at the same time simplicity of microbial systems. We were running a process on the basis of chicken litter, and it seemed that the chemical production was stopped, even though we had raw materials for that carbon source and so on. And so we concluded that there would be lack or shortage of some minerals or some growth factors, and didn't have time to check all of them, to check chromium, manganese, zinc, whatever, vitamins. So we bought some 12 liters of blueberry juice from the ICEI in Sweden, and Anneli went to the site, and then she phoned me, "Are you sure that I will pour that good blueberry juice into the rubbish, into the waste bioreactor?" But it helped, as you see from the pictures, the production, it shooted upwards, and that was very simple. The results of the above project have been published, and the key for the measurements was the nucleic magnetic resonance, which was a splendid method for this purpose. In this case, we knew everything, how the substrates were used, what products were produced, and so on and so forth. And Professor Laatikainen will tell about this on tomorrow in his lecture here. And then we come to the patient side. Because in modern times, so many of us, we suffer from different kinds of stomach problems, and these are not specified and they are not known to medical science that well. It's like somewhat like the diseases caused by the molds. And here is a patient sample, and one red colony is representing 100,000 E. coli cells in the intestines of a young guy. And there are some blue ones, but you can see that all his digestion is taken over by E. coli. So that's called small intestinal bacterial overgrowth. And in lab tests, there are no abnormalities. But the patient is cachetic. He is suffering from several severe pains, and so on. And on the right-hand side, we see the immunoplot or dot plot results with his serum, and we see that there is, besides against E. coli, there is the activity against some other isolates, one of them being Staphylococcus aureus. And so that's maybe a strain which is either on the skin or on the duodenal tract. And so you can see what happens if you teach immunology to someone. He might be lecturing in some later time. So Jukka was my supervisor, and I learned from him what I know about bacterial immunology. And so this is then one application. We can have probiotics, and they are plentiful on the shelves of the retail shops. But together with Dr. Jaakkola, we started to experiment the different combinations of probiotics together with prebiotic substances, fibers such as flax, combined with berries, and so on. And here we can see that this is on the logarithmic scale, one product was superior. That's called Acidophilus forte. It was 100 times approximately lowering the content of E. coli. It was attenuating the growth of E. coli. We need E. coli. Each and every one of us, we have E. coli most likely in our intestines. But this patient I was telling you about, he was suffering from the overgrowth. So this is the importance of balance, attaining balance. Then there is another probiotic product which is not named in here, and it was quite inefficient. And the third one is Kefilus or GG, which is the famous golden korba, which was purchased by Value Company in 1986 when I was there as a researcher. And it later on became a real famous trademark, and it was licensed all over. This is a slide from a publication of Dr. Hell from Austria, Salzburg. And it's a complicated one. It's illustrating the condition on the epithelial surfaces in the intestines. The layer of the human cells is only one cell thick. So it's rather easy for the bacteria to penetrate, and that's causing also problems. And then we repeated this probiotic experiment by using the strains from sauerkraut, which is a traditional food in many countries. And the result was about the same as it was with the specified strains, together with the prebiotic flax. This is essential. We need the fiber, we need the right microbes, probiotics, to keep the balance. And the balance is actually originating from the duodenal tract. We found out that when we were using PMEU device, we grew E. coli and Klebsiella separately. There are two enterobacterial species. And then together in one PME syringe. And they grew, to our surprise, equally well when they were together with 50% of the resources. So the conclusion, they must have a kind of symbiotic relationship. And this illustrates the consequences of this relationship. We don't have time to go into details, but E. coli is producing acid. It's an acid-making machine. And you remember when the stomach content was sprayed into the intestines, into the duodenum, then pancreatic bicarbonates were needed to neutralize it. But also the microbiome is keeping the pH. Because in our lab in the PMEU, always when we had the Klebsiella together with E. coli, it always neutralized, and in the end the pH was 6, which is exactly the pH of the healthy duodenum. So that's a beautiful example how our body system is in a way cooperating with the microbes. And another evidence, this was already the slide, was in the Jooni's presentation earlier today, and this is a kind of a proof that there are about the same amount of mixed acid fermenting strains and the butylene glycol fermenting strains in our upper intestines. And Klebsiella is a funny thing because it's causing deadly disease if it goes to the lungs, but it's needed in the intestines. So can we call it a pathogen or not? It depends. This is a book published in 2012. We started to write books that time, and this was the first one related to the alimentary microbiome, as we had studied it with the PMEU device. And another proof from this big hospital in Austria, Salk in Salzburg. They had collected for 3 years all the isolates from the infected bile tract. And the main groups of organisms were, first of all, gram-positive cocci, and second, the Enterobacteriaceae. And in there, it was about 50-50 between E. coli and Klebsiella enterobacter and other butylene glycol fermenting strains. And here we see a slightly distorted bacterial intestinal balance. We see E. coli, but less than that there are Klebsiellas. So E. coli is starting to dominate, and besides that we have another villi there. We have Bacillus, which belongs to the soil. It's not an intestinal bacterium. So this patient was suffering from mild conditions, floating, gas production, acid production, and so on and so forth. Then we studied and published together with Professor Hänninen this piece of work where we were using PMEU in a way that we were leading the gas from previous or preceding culture into the next one, and we saw the influence of the gas liberated by bacteria, and it was proven that the CO2, carbon dioxide, was the one that boosted the growth of the adjacent bacteria. And in fact, the lactic acid bacteria produced carbon dioxide, which was boosting the clostridial growth, the butyric acid bacteria, which are the goodies also. And so this thing that the probiotic lactic acid bacteria keep the intestinal microbiome in active state, it's preventing diseases. It's preventing the nasty toxin-producing strains from attaching and rooting to the surfaces. And in a bioreactor, the same thing, that there was the boost by the carbon dioxide. And we used that for the detection of Clostridium difficile in Austria. Then there are examples that in lower intestines, the propionibacteria, which are going into the spine, they can cause perhaps 40% of the lower back problems. And that was the Danish study. Where is Robert? Robert is now a visiting scientist in Aarhus, Denmark. So this was another proof of what happened in the lower intestines. This is from a bioreactor, but there the lactic acid is converted into other organic acids, propionic, butyric, and acetic acids, as well as into a little bit of ethanol. So this conversion, if it happens there in the nerves, it's depriving the nerves from their major energy source, which is not glucose, it's lactic acid. And propionic acid, it's, as we know, it's also cutting the surface appendixes of bacteria, but it might be detrimental to the nerves, and it can cause these problems. But then we can use the same types of bacteria for good purposes. We can increase the production of greenhouse plants by 50% in 2 months by using a clostridial strain, which is fixing nitrogen autonomously. The hydrogen is coming out from our intestines, from the anaerobic bacteria. That is produced everywhere. We can make it as an energy source, the biohydrogen. And then there are some examples on the research on different pathogens, like Campylobacter, Mycobacterium, and Salmonella. And here is a proof how Salmonella is loving oxygen in our intestines. It's penetrating to the intestines in order to get the oxygen from the blood circulation, to get aerobic metabolism. And that's proven by the production of the anchoring fimbriae. And during this Apple project, which was already mentioned, we studied the utilization of chicken litter, and the nasty stuff was converted into nicely smelling yellowish milk containing lots of biochemicals and valuables. And so when finishing this lecture, the slides last night at 1 o'clock, I started to become poetic. And so this is a poem about biofuture. Thank you very much.
Thank you very much, Elias, for this very nice talk. There is a question.
Thank you, Elias. Is there a difference in the microbiome for people that are vegetarian, vegan, gluten-free, etc.?
Of course, yes. Yes, that's right. Because actually there has been an extensive study, international study, and they found out that there are 3 different basic patterns based on mostly on diets. So one is the Western type, which is developed to people consuming lots of meat. Then there is the African type, which is based on use of cereals. And then there is the Eastern type, or Mediterranean type, which is based on that type of diet. So these 3 are the basic structures. And as individuals, we might have any one of them depending on our own lifestyle and or a combination. But basically, you can very easily see from the intestinal analysis, microbiological analysis, what kind of food the patient is consuming.
Okay, one final question.
It's the question is quite much the same, but I was eager to know, is there any research when we are considering this mold hypersensitivity syndrome? What is the microbial composition in the gut? Is there any information about that? Because I think that there must be some connection with the gut microbiome and these hypersensitivity reactions.
That was a very good question, and I could try to answer to that, and it would take until tomorrow morning. But in principle, this means what Karina is telling us, that as our immune system is connected to this microbiological world and reality. So it means that whatever we are subjected to, or whatever the exposure is, we react to it. And so we can have the same types of antigens, both from getting them from the environment or from the food, as well as from the intestinal flora. So it's extremely important to keep the intestinal microflora healthy. So if we want to treat a patient, we don't know what's the disease even, but we can try to balance the microflora.
That's about 50 years ago, cows were given toxins, and the milk was used for protection of human beings. Have you heard about such experiments?
Yeah, it sounds like passive immunization.
But it is not, in Finland, in Helsinki, not very general, generally used. Have you given doctors who have treated persons with immunized milk?
There was some company producing this, but then it was for sportsmen, and somehow it was not used for the treatment of diseases. And I think one complication is the legal matter, and it's not easy to get the permissions, even though this is, to my mind, it's rather quite or almost completely safe. Of course, if you are allergic to milk, then it's not safe. If you are allergic to egg yolk, it's not safe. But otherwise, it's one of the safest methods to treat infections.
Okay, thank you very much. One final question. When should we come back? Because we are a little behind in the schedule. Actually, now we have only 10 minutes for lunch, so what would you suggest?
Yesterday I asked the audience that should we skip the lunch, but no one advocated that. So we have to, most likely we need the lunch. And so I think that if we have a half an hour break, and so I feel sorry now because you take that up. I have consumed the time.
No, it's the sloppy chairman.
I wish you bon appetit.
20 past 1 we will continue, so please be in time.